Today we're going to discuss how to find determinants of a 3 by 3 matrix. So we might have to save Cramer's rule of 3 by 3s for tomorrow. So obviously you had to know this is kind of coming. The ultimate goal is that I want to use Cramer's rule with a system of equations that is 3 equations, 3 unknowns, so we can kind of phase out the other way that we did it. The reason this might be a better method rather than the inverse that we practiced the other day is that if you have one where the coefficient matrix doesn't have a nice inverse, well then it's not an ideal method. So this method is a little bit more ideal. So there's a little trick to kind of like the setup on how to find the determinant here. So you're always going to start with this first value, whatever's in row 1, column 1. And that value is going to keep the sign. And then what we do is we're going to make a determinant of a 2 by 2. And essentially what you do is you take everything that's not in that row or column. So nothing from row 1 and nothing from column 1 is going to go in this determinant. So the 4 letters that are left are E, F, and HI. So now we're going to move down a spot. So now I'm doing letter D. So now this is going to be the opposite sign. So now I'm subtracting this middle value. And again, I'm not using anything in this row or this column. So this column, that column's never going to be used, so it's more the other row. So the values that are left are B, C, and HI. Now we're going to move down a spot, and again, now we switch, and now you're keeping the sign. And the values that I'm not using cannot be in this row or column, so that 4 letters that would be is B, C, E, F. And then obviously we did a ton of practice on determinants yesterday. You would have to calculate the determinants of these values here, and then again you're just going to get one single number that would represent this 3 by 3 matrix. So let's go ahead and try one. So here we have this 3 by 3 matrix, so we're going to start by taking that top number, and notice I keep the sign, so I'm not using anything in this row, and for the first time we're excluding the first column. So my 2 by 2 matrix would be 3, 4, 8, 1. And now I'm subtracting the second term, so it's minus a negative 9. Yes, that'll turn positive, so yes, you could write positive right off the bat. So now I'm excluding the middle values. So my 2 by 2 matrix will be 1, 0, 8, 1. Now I'm going back to using the same sign. So now I'm adding a negative 3. And my 2 by 2 values will become 1, 0, 3, 4. And now we have to proceed. So we're going to keep this in parentheses. So when I multiply on the diagonal, 3 times 1 is 3, minus 8 times 4 is 32. I know this double negative will change to be a positive. On the diagonal, 1 times 1 is 1, minus 8 times 0 is 0. Then I have minus 3. On the diagonal, 1 times 4 is 4, minus 0. So here we'll have 4 times a negative 29, plus 9 times 1, which is 9, and minus 3 times 4, which is a negative 12. So out front here we get negative 116. Positive 9 minus 12 will be negative 3. So the determinant of this equals negative 119. So that's all for today. We're going to make sure we're really feeling comfortable with this tomorrow, and then we're going to apply this to Cramer's rule in solving a 3 by 3.